The limit as x goes to infinity of x minus 2 over x squared plus 1, which is the limit of a rational function where the degree in the numerator is 1 and the degree in the denominator is 2. We see that the degree in the numerator is strictly less than the degree in the denominator, and so this limit is 0. But to confirm it, we take the rational expression and divide by the highest degree that appears in the denominator, which is x squared. And so we will take every single term and divide by x squared only. 1 over x squared would go to 0 as x goes to infinity. 2 over x squared would go to 0 at x goes to infinity, and x over x squared simplified to 1 over x, and 1 over x go to 0 at x goes to infinity, and x squared over x squared go to 1. And so we would end up with 0 minus 0 over 1 plus 0, which is 0 over 1 or 0. And so this limit is 0. The limit at x goes to infinity of x minus x times square root of x, the whole quantity over 2x to the power 3/2 plus 3x minus 5. Even though this is not a rational function because the numerator is not a polynomial and the denominator is not a polynomial, but we can still apply the same technique. Notice that in the numerator, we can rewrite this limit as x minus x to the power 3 over 2, because the square root of x is the power 1/2, and x times x to the 1/2 is x to the 3/2 power. 2x to the 3/2 plus 3x minus 5 in the denominator. And so the leading term in the numerator is minus x to the 3/2, and the leading term in the denominator is 2x 3/2. Since they have the same power, we see that the limit is the ratio of the coefficient in front of the leading terms. So the limit is negative 1 over 2. To justify this, we can take this expression and divide it by the highest power in the denominator, which is x to the power 3 over 2. And we see that negative x to the 3/2 divided by x to the 3/2 is negative 1. And so the first terms go to negative 1. The next term, x over x to the 3/2, is 1 over the square root of x, and at x go to infinity, the terms go to 0. And 5 over x to the 3/2 would go to 0 at x go to infinity. And similarly, 3x over x to the 3/2 is 3 over the square root of x, which also go to 0 at x go to infinity. And the term 2x 3/2 divided by x 3/2 is 2. And again, the limit is negative 1 over 2. The limit at x goes to infinity of the quantity, the square root of x minus the square root of x squared plus 16. If we try to evaluate infinity, we would have infinity minus infinity, which is indeterminate. And so we will find a way to rewrite it so that we can introduce a fraction. To do that, we multiply the conjugate, which is the well-chosen one, the square root of x plus the square root of x squared plus 16 over the square root of x plus the square root of x squared plus 16. This is a binomial because there are two terms joining by the negative sign. So the conjugate is the two exact terms joining by the plus sign. And we multiply the whole expression by a factor of 1, so we will not change the limit of the original problem. The limit at x goes to infinity. The product of the conjugate in the numerator is the difference of two squares, and so the numerator is the square root of x squared minus the square root of x squared plus 16 squared, and the denominator is the square root of x plus the square root of x squared plus 16. Simplifying the numerator, we have x minus x squared plus 16 inside the parentheses, the square root of x plus the square root of x squared plus 16 in the denominator. At this point, we will employ the trick that we have been using by dividing every single terms by the highest power in the denominator. The highest power in the denominator is the square root of x squared. And so we would multiply 1 over the square root of x squared in both numerators and the denominator. Notice that in the numerator, the square root of x squared is simply 1 over x, and so we would have negative x squared over x plus x over x minus 16 over x. And in the denominator, we have the square root of x over the square root of x squared plus the square root of x squared plus 16 over the square root of x squared. And so in the numerator, we end up with minus x plus 1 minus 16 over x. And in the denominator, we have the square root of x over x squared, which is 1 over x, plus the square root of x squared over x squared is 1, plus 16 over x squared, where we combine the radical in the quotient. Now, as x goes to infinity, 16 over x goes to 0. 16 over x squared goes to 0. 1 over x goes to 0. And negative x goes to negative infinity. And so we would end up with negative infinity plus 1 minus 0 over 0 plus the square root of 1 plus 0, which is negative infinity over the square root of 1, or simply negative infinity. This limit doesn't exist, but it doesn't exist in this special way. What this means is that if we were to graph this function at x goes to infinity, the graph decreases without bound.